Okay, so I would like to explain how one would prove bijectivity for a function. So before we actually start proving bijectivity, you want to understand what needs you need to fulfill in order for a function to be bijective. So for a function to be bijective, it needs to be both injective and surjective. Injective, or one-to-one, means if for all a and a prime on a, f of a must equal f of a prime, which implies that a equals a prime. To be surjective or onto, if b equals the range of f for a function map f of a to b. So essentially, each input has a unique output for injectivity, and for surjectivity, every possible output has at least one input, and then when it's bijective, it fulfills both of those needs. Each input has a unique output, and each output has at least one input. I'm a very visual learner, so I feel like having these graphs really helps me understand the topic better. So for injectivity, for the injectivity diagram, you can see on the left-hand side, you have x1 to x3, and on the right side, you have y1 to y4. So x1, x2, x3 maps to y1, y2, y3 respectively, but as you can see, y4 has no input. For surjectivity, x1 to x4 maps to y1 to y3. But as you can see, x2 and x3 map to y2. This shows that every output has at least one input. So it doesn't really matter like the size of the set itself, but as long as it follows that, fulfills that need. And then you can see over there for bijectivity, x1 to x3, and then y1 to y3. It doesn't necessarily matter that x1 maps to y3 and the x3 maps to y2. It still fulfills both requirements, so it proves that diagram, that function is bijective. So with the time that we have right now, I'm gonna kind of delve into the bonus facts. This just kind of describes something that would be well-defined versus not well-defined. For something to be well-defined, it would need to have each map for each X or Y have one input or one output. I feel like that's a really good way to explain it. And then not well-defined, as you can see, X1 and X2 map both to Y1. So that means Y2 wouldn't have an input, wouldn't have an input. So yeah. And then for my example, I wanted to do the show f n to z is bijective by using the equation f of n. When n is even, you use n divided by 2, and then when it's odd, you use the negative quantity n minus 1 over 2. So for the proof for the injectivity, we want to do suppose m equals f of n, which equals f of n prime. That means that if m is greater than 0, then m divided by 2 is equal to n prime divided by 2. That shows you that m is equal to n prime. And then if m is less than or equal to 0, then you plug in n, or the negative quantity n minus 1 over 2 is equal to the negative quantity n prime minus 1 equals 2. This proves that n is equal to n prime. And then as for surjectivity, you let m be on z. So if m is greater than 0, choose n to be 2m. And when you plug it into the function f of n, you get 2m divided by 2, which is m. And then if m is less than or equal to 0, choose n equals 2m plus 1, being odd. And then when you plug that into f of n, you get the quantity negative 2m plus 1 minus 1 over 2, which is f. So overall, that proves that f of n is both surjective and injective. Hence, the function is bijective. So with the time that we have left, I wanted to kind of delve into an example that is not bijective. So for the example, we're using f on R to be defined by f of x equals x squared. So as you can see with the graph, it kind of points out why the function isn't injective or surjective. So for the not injective portion, it's considering the fact that we have f of 2 and f of negative 2, which both are equal to 4, which violates the f of a is f of b, with b equaling, say, a prime. because it implies if f of A equals f of B implies that A equals B, but in this situation, A does not equal B. And then for not surjective, there's kind of like two portions to this. There's no input in R that will have a negative input, R being all real numbers. And then two, because negative numbers will not have a corresponding unique output. As you can see, the graph is strictly over x equal or y equals 0. Oh, shoot.